Oh, so you just went ahead and skipped the first step? But it's essentially the law of sines, right? Sine of A over A, well in this case, sine of C over C equals sine of A over, well I should have made that A, but I made it H. Sine of A over H. This is, I'll let you pick it up just in 1 second here, Dave. This is exactly what we did on Thursday. If you have a triangle and you have a side and an angle directly opposite of one another, use the law of sines to find out everything else you need to know. All right, go, finish. So you cross multiplied. Right. Over the sine of 24. So you divided this. Well, that's really horrible, and I apologize. And what did you get? Nearest 10, so 5.3. You said 5.341?
523.
Oh, a big number.
Yeah.
Yeah, 5.3 wouldn't make any sense, would it? 523.1. Got it. Very good. Very, very good. That's exactly what you needed to do. Exactly. There are 3 parts of today's lesson, all of which are pretty independent of one another, so it's very ambitious of this book to put them all in the same section. But it's all going to be based around what we did last Thursday, which is basically just this proportion. This proportion fuels everything we're doing today. Let's see, which way do I want to go first? Okay, I got it. You mean darn. Hey, Caleb, what is my third angle in this picture? Very good. How'd you get that? It's subtract, right? Easy peasy, rice and cheesy. However, what if, just go with it, what if we didn't know this angle, and we had to find that angle, and you had to do the law of sines? Now, tell you what, real quick, what would you say this was, 113? Somebody who's really quick with the law of sines. Cody, I want you to real fast find this third side for me. What was this one, 24 degrees? Yeah. I just need you to find that third side for me really quick. No, I just need the number. Yeah. To prove my point, I need the number itself. David, you got it? Ooh, bested. I'm sorry, I didn't explain myself. What'd you get? 706.1. Okay. Now, let's say this was given to us in the problem. Let's say this was given to us in the problem. And we have to find angle B. Watch what happens when you use law of sines to find an angle. You're going to do it the exact same way. Sine of, let's see, this, we could then, let's just use what we've got. Sine of 43 over 523.1 equals sine of B over 706.1. Right? No different. Only difference is we're looking for an angle, not a side. Everything's looking great right now. However, when you cross multiply and divide, let's see, so it's going to be 706.1 times sine 43 equals 523.1 sine of B, correct? What does? When you divide this by 523.1, are you sure you're in degree mode? Let me just check that out myself, make sure. So we're going to find, so how do I find an angle? What do I have to use? I'm going to do that whole thing. I'm going to get a fraction equals sine of B. But I'm looking for B itself, not sine of B. So how do I get rid of the sine? Sine inverse. Sine inverse of 706.1 times sine 43. Oops, a minute. Close parentheses. Now actually, I need to go over, you don't have to be doing this, I'm just showing you. I'm going to make 2 parentheses, because now I need to divide that by 523.1. Nope, I need another set of parentheses. 1 around the whole numerator. Therefore I need a... I know. Don't steal my thunder. My thunder is everything to me. Okay, make sure you're in degree mode because you're using degrees. Quit. And Caleb, what did you say that angle was earlier? 113. 113. Why isn't it giving us 113? No, that's right. The calculator is doing it correctly. Who has a unit circle readily available? Disappointed there's only that many people. Okay, I'm going to ask you a question. What is sine of pi over 4? What is sine 3 pi over 4? Do the same exact thing, right? What is sine of pi over 6? What is sine 5 pi over 6? Same thing. Every sine value has a twin. And because of that, now if I were to just say, Devin, you have yours out? Devin, if I said, find me a sine value that is radical 3 over 2, what would you tell me?
Can I repeat the phrase? Any sophomore last name begins with the letter T. There's, the running a spring picture. Like if I said like the little game of the sign, sophomore last name.
Your hair looks like.
Okay. Now, what is an angle that has a sine value of 3 pi over 2? I mean, radical 3 over 2. I just want, what's the degree that with sine of radical 3 over 2? What? What is it? 270. Here's what I'm getting at. Every single inverse sine that you do, it could either give you an acute and an obtuse. They're the same exact thing. So your calculator doesn't know that you want 113 because sine of 67 is the exact same thing as that. Almost every single acute angle, or excuse me, obtuse angle in a triangle has kind of a brother triangle, which I will show you now. What does that mean? It means all the information that I've listed on this, see angle, side, side right here? I could draw a triangle. Hold on. Basically, anytime you have an obtuse angle in a triangle, it could be misleading. When you do the law of sine, it's only going to give you acute angles. That's why you can't use law of sine to find the angle of a triangle, because if one of them is obtuse, your calculator doesn't know how to tell you that. It doesn't know how to tell you that. So what we are going to do is we are just going to look at that scenario and figure out how do we know if our calculator is giving us the right answer or not. Yes, but I mean, what's one test that we can do, and this I'm not expecting you to know this, I'm going to tell you. What's one test we can do to find out whether we have one unique triangle or two triangles? Because we just given this information, if we had written down 67, technically we'd be right, but we'd obviously be wrong because that's not 67. So I'm going to show you how to do that.
So it's right and wrong at the same time?
Yes. Okay. Somebody tell me, what's the straightest distance between 2 points? Straight line. That's right. So this is going to come into place when you have side, angle, side. No, I take that back. It was the only one in geometry that we couldn't say, and it's because it did a cuss word. If you have angle, side, side, what that means is, if I give you an angle, and then a side length, and then another side length. If I give you an angle, a side, and a side, like angle A, side B, and side A. A classic law of sine situation. The shortest distance that this little pendulum right here could possibly be is the straight line to reconnect with the bottom there. And a straight line forming another straight line forms a right angle. Let's call this angle A. Okay. Good. Good. There is a chart in your book that's about to demonstrate exactly what I'm going to discuss. So, if we'll all open up our books to section 6.1. This is a first. I don't usually ask you guys to look in your books during a lesson. Yeah. It is page number... Yes, but I'm looking for its exact section. Page 647, there's a little blue box. There's a little blue box on page 647. Everybody see that? Now, what that box is referring to, what that little box is referring to is this set of problems right here. There are two sides and an angle given of a triangle. They've given you two sides and an angle. They want to know, determine whether these measures give you one perfect triangle, two triangles, like the one we just looked at had two potential triangles, or whether they can't form a triangle at all. Now I'm going to show you how to do that using that little blue box. So the first thing we have to do with these is just figure out, can this even be a triangle, and how many could it possibly be? So, let me go back to my little drawing. Everything I'm about to draw on the board is coming straight from the little blue box on page 647. Alright, so we're looking at the situation where they give us side A, side B, let me make these lowercase, side A, side B, and angle A. Okay? Side A, side B, and angle A. That's what they give us in each one of these, more or less. One side an angle and a third. And another side angle. Okay. What is sine of A? A over B. Yeah, opposite of our hypotenuse. Sine of A is A over B. Very good. Now you can only use SOHCAHTOA for a what? For a right triangle, that's correct. Sine of A equals A over B. First thing you're going to do, if you have an acute angle given to you in the problem, first thing you're going to do, if you have an acute angle, you are going to find out more or less what sine of A is. However, the side that we're interested in, the side that's going to dictate this whole thing, is the length of A. The length of A tells us everything about these problems. If that's the shortest it can be, what if A is only that long? Could you even have a triangle here? No, it's not long enough. It can't connect to the base. You cannot connect and there is no triangle. So what we have to do is we're going to simplify this little formula right here into something that will tell us, is A big enough to have one solution? Is it long enough to have two solutions, where you could have it here or here, like the one we looked at in the DOM? Or is it so big, what if A, because remember that top angle isn't, that could be anything, so this piece is just going to swing on a pendulum. Is it so big to where you can form one triangle, if it's going out here, but it's too long to form another one, because you can never reconnect with the base, it just swings wide. All of this demonstrated right here in the book. The second little triangle is the one solution, if it is the perfect length. That little third triangle right here is what I showed second. If there's no triangle, if it's too short, and then if there's two triangles, if it is a good length. So, what we're going to do is do B sine A. That's an A. That's a little A. What we're going to do every problem, we are going to take our angle, and we're going to multiply it by the side not opposite that angle. So if this was C, we wouldn't do it with C. We would do it with the other side. We're going to take that angle, sine of that angle, multiply it by the side, and see if it equals this.
You're now ready for any sophomore like not and one
That's great. Okay, so number 17. Number 17. What's my angle? 40 degrees. What is the side not opposite 40 degrees? 15. That's right. So we're going to multiply 15 times sine 40. Somebody do that for me. 15 times sine 40. What is it? 9.6? All right. 9.6, what that represents is the shortest possible distance length that this can be. If it is 9.6 exactly, if this said 9.6 exactly, then that would be a right triangle. It would be one perfect solution. Because the shortest distance that could be given by B sine A, but it's not. We'll get to that in a second. It's not. this is bigger than this, meaning it's greater than that minimum possible distance, which means it could be two triangles. Because when it's, let me go back to my drawing, when it's bigger than that side, just by a little bit, you can have one triangle here or another triangle here, depending on which way this thing's swung. So, next thing we do, it's all about an order of operations. First thing you're going to do every time, actually I kind of butchered the order of operations thing first. B sine A. You're going to do B sine A. These are just arbitrary. This means side not opposite the angle. And you're comparing that to A. Here are your three possibilities. If B sine A equals big A equals little a perfectly, then you're looking at one solution because it is a perfect right triangle. If B sine A equals little a perfectly, you're looking at one solution because it is a right triangle. If B sine A is less than A, if B sine A is less than A, then you're looking at potentially two solutions. And I'll draw a little picture to show what I mean by that. It means it could be here, or it could be here for that third side. Thank you for not being rude or anything. If B sine A is greater, I keep making this lowercase, is greater than your third side, then it's no solution. Wait, yeah. It's no solution because you're looking at this scenario. It's just not long enough. Too short.
So, let me get this straight. Like that one angle, I think that angle would be sine A. That doesn't move at all. Like that can't be more or less at all, depending on how big that one side is.
Are you looking at the first one?
Yeah, that's the first one.
Yeah. What were you saying?
So like that angle is not going to change. The only one that's going to change
Yes.
is the side you're trying to define.
Right, because there are two sides in an angle given to the problem. That's given to us. And we are trying to determine what everything else can be. But we have this gray area which we need to figure out what's going on. Okay? Now, there is one little stipend here. This is assuming that A is less than B. Or equal to. No, just less than B. This is assuming, and this is important, that A is less than B. If A is less than B, this is the test you will do.
What would be less than that?
That in just a second. If A is less than B, you will do this test. If A is greater than or equal to B, in other words, if this side is either bigger than or equal to this side, then it's going to be that situation where it's too long to form two. And it'll automatically be one. So we're making all the possibilities here. That is all for A is less than B. If A is greater than B, it's one solution every single time. Sorry, I wrote that so illegibly. If A is greater than or equal to B, there's one solution every time. Every time. So let's go back to that last problem. We may have done too much work because I didn't think to do this before it. Let's look at our side. Is A less than or greater than B? It's greater than, which puts it in that lower scenario, and we didn't even have to do this because it's just going to be one solution. Because this side is so long that it'll form an angle way out here, or a triangle, but if you tried to swing it to make two triangles, you couldn't do it. So one solution. What about here? Is A greater than B? No. So this is the one we have to do the test for. So somebody punch in B sine A. 18 sine 60. Let me know what you get. 15.6. So, is B sine A less than or greater than our other side? It's less than. So let's go over here. Oh, one more. B sine A is less than the actual side length So it's a two-solution problem. Very good. And I'll show you how to solve for those solutions in a second. Right now, all we're going for is how many solutions are there? All right.
Is that what we're doing now?
No, there's actually pretty packed lessons there. All right, so this was one solution, two solutions. C, or excuse me, 19, is the side opposite our angle the biggest side. I said that wrong. No, I didn't. Is A less than or greater than, will normally be, but C in this case. Is it greater than, less than? So what does that mean? One solution. If the side opposite our angle is the biggest, it's one solution, period. Because it's too long to possibly connect and make two triangles. What about 27? Is A less than or greater than that other side? Less. So we need to do the test. Somebody punch in 16.1 sine 37. What do you get?
9.7.
9.7. So is B sine A less than or greater than our side? Less than. So how many solutions are there? Two. Very good. Two solutions. We're going to skip 21 for a second. I'll explain why in a second. 29. Do we need to do the test?
Wait, I'm confused. When do we know we don't need to do the test?
If the side opposite the angle is the biggest side.
What do you see, right?
In this one? If the side opposite the angle, matching letter, is the bigger of the two sides, you don't have to do anything. It's one solution.
Okay.
But when it's smaller, you have to do B sine A. Okay. So this, where am I? This one. So 24 sine 58 is what? Yeah, I'm asking you what the test gave you. 24.1 sine 58. What's that give us?
20.4.
20.4. Is our side long enough? Is it the same as, less than, or greater than? So how many solutions? Two solutions. 23. Let's just keep going. We're going to have to do the test. Allie, what's the test going to give you? 40 sine 30. 40 sine 30. 20. Is our side, is B sine A greater than or less than our side? Is what you just found bigger than or less than this? It's bigger. How many solutions? None. No solution. Because it's obtuse and that's a whole different ballgame. This is all for acute angles. I'm glad you asked, so just give me a second. No solution. It's no solution because that chart we just wrote down. That chart said that if B sine A is greater than A, there's no solution. Because that's a scenario where the side's not big enough to connect in. Because the straight line between those 2 points is B sine A. It has to be at least that distance. You should love these. When you get no solution today, that means you don't have to do anything. All right. Last one. B sine A. What is it? $12.7. Is that bigger than or less than our side? How many solutions? None. Very good. No solution. Solution. 21's obtuse. Obtuse is easier. What's the whole law of sines built around? It's built around the theory that the bigger the side, the bigger the angle, right? Well, if it's obtuse, doesn't the side opposite the obtuse angle have to be the biggest side? Because you can't have two obtuse angles in a triangle.
So that automatically means that.
No, it automatically means one solution. Because you can't have two obtuse angles. What was this whole problem? Where did it come from? It came from where you were looking for an angle that might be obtuse. Well, if they've given us an obtuse angle, there's not going to be another one. Or, yes. But what if this isn't the biggest side? Now, technically, if you draw it, that's impossible. So if it tries to trip you up and be like, oh, this side's 10, and it's opposite 112 degrees, and this side's 50 or 37, it's impossible, and you just write no solution. They're trying to pull a fast one on you. One or none, yeah. If this is the biggest, one. If it's not, none. One or none. The only complicated ones are these, where you have to do the test. Now, only thing you have to do from here is the same thing we did on Thursday, and I know you can do it. Like 17. All we have to do is finish the law of sines to do that. So that would be sine 40 over 20 equals 15. Sorry, I'm writing really bad today. 15 over sine of b. And you just solve it. 15. Oh, I did these backwards, didn't I? Yeah, I messed that up. Sine of b. So cross multiply. Of course, we already found 15 sine 40, but we'll just do it again. So 20 sine b equals 15 sine 40. Yes, you will. Divide both sides by 20. Yes, I would.
Any juniors that want to have this same teacher taken.
Geez, that's totally. This is
Oh, so
so bad.
you've got a little bit.
15 sine 40. Where am I? 15 sine 40 over 20. Good question. You will do sine inverse. Now, you need to open up a separate parentheses just for your numerator. 15 sine 40. Close off your sine. Close off your numerator. Divided by 20. Then close off the entire sine inverse. Enter. 28.8 degrees. Every time you only have one solution, you're going to be looking at a triangle like this. And you're looking for an acute angle. So this is going to be accurate. 28.8 degrees is correct. The only time you can't trust this is when you have a two-solution problem. And I'll show you how to do that in a second. So 28.8 degrees, you have angle B. Now that you have angle B, can you find angle C? Yeah, how? Addition, subtraction, just like Caleb did earlier. And then you can do law of sines again to find side C. Questions about that one problem? We're going to do a two-solution problem, but is there questions about how you would finish number 17? Yeah, you have to solve the triangle to find everything. You find this angle, subtract to find your third one, then just do the law of sines. No longer than Thursday. You're still doing the same thing. The only difference is your first step has an inverse in it. But now, two-solution problems. These are going to work the exact same. A two-solution problem. If you don't listen to anything else, well, I'm not going to say that because I want you to listen to everything. But I do not want to have to answer 1,000 questions on this later if I'm going to say it right now. So please pay attention. If you conclude that one of your problems has two solutions, here's what's going to happen. You're going to have two full triangles. You're going to have angle side A, side B, side C, angle A, angle B, angle C. And then over here, you're going to have a whole separate triangle. And the only things that these triangles will have in common is what's given in the problem. 16, 16, 18, 18, 60, and 60. Where these two are going to differ, because it's two solutions, one of them is going to be an acute angle for B, the other one's going to be obtuse. So that when you subtract that and add that to the 60 and subtract, your third angles will be different too. So, we just start out doing the law of sines, just like before. Sine 60 over 16 equals sine of B over 18. Cross multiply. Divide by 16. We're ready to punch it in the calculator. Now, which answer is my calculator going to give me? The obtuse or the acute? That's right. It'll always give you the acute one. All right, so 18 sine, oh, crikey. Sine inverse, since I just want to do it all at the same time. I said clear. Sine. Oh, did you already find it? Well, I'm going to go ahead and punch it in here just so people can see it. But yeah, nearest degree. Because we're looking for angle B, I'm just going to go ahead and sine inverse that whole side. So close off the angle, close off the numerator, divided by 16, close off the whole fraction, Enter. 77 degrees. Very good. So that is angle B. Yes. So that's angle B. Now, let's go back to the one we did in the DOM, because from here it's actually very easy. There's no other complicated step to it. Back in the DOM, yeah, yes. Back in the DOM, you said this was 113, remember? Yes? Does anybody remember what it was when we actually solved for it? It was 67. It was the supplement of this. Anytime you have two solutions, your calculator will give you this one, the acute one. The other one is just the supplement to that, which is a very simple proof, but I won't bother doing it. Just trust me. Whatever the first one is, the other one's going to be the supplement of that. So, back to our problem. If the first one is 77, what's the other one? 103. This one is 103. Making, what's the third angle on this triangle when you add and subtract? This one's 43. This one's 17. Now all you have to do on those is do the law of sines one more time with their individual C angles to find side C, and you're done. Nope. They're different. Side C are different. Oh, no, it doesn't matter. I would use the one they gave you in the problem because you didn't have to round it. Yeah, I'd use A for both. Yeah, it won't change anything. Yeah. Oh, yeah, they'll be different. Yeah. Because the angles opposite them are different. You'll just have to use this angle for this one and this angle for that one. You want to just do it real quick? Hold on. Make sure I can write this down before you go. Hold on. Say that one more time, Hannah. Check. You got it. And the other one's going to be sine 60 over... You got it. You are rocking and a rolling. Well, the two solution problems are a little bit more work, yeah. No, that's correct. You only use inverse when you're looking for sine of an angle. Okay. I'll tell you what. It's going to set us back a little bit, but heck, we've been set back so many times this year. What difference does it make? I have no problem just focusing on this portion of the section today and just looking at 6 or 8 problems, but if we do that, I want them done today before you go, and I really want people to focus on this. Or we can just keep going and learn the rest of the section. If we learn the rest of the section, you have till Wednesday, because remember, tomorrow I'm not going to see you. We'll have a vote, and you're going to have to respect it one way or another. Here are your options. If we cut this off right here today, you're only going to have 8 problems, but they're due before you go. If we decide to move on, it's due Wednesday. You'll have 2 days to get the work done, but there are 2 more things you have to learn today. If you prefer, you just vote for yourself. This is democracy. If you want to cut it off here, raise your hand. Oh, okay. Well, you want to keep going, raise your hand. Alright, so we're going to stop. Alright, so what problems were those? It's page 651, I think, and it's just going to be 18 through 32. Even. Page, I think it's 651, 18, nope, 652, 18 through 32 even. Page 652, 18 through 32 even.